Hi everyone, so welcome back to Codera. So in this video we'll be discussing the problem B from the latest CodeForces round 750 division 2. So let's read the problem statement. So the problem says that you have been given an array of length n and you want to calculate the sum of elements of the array, okay? And Luntik calls a subsequence of the array A nearly full if its sum is equal to the sum of the number of elements in the sequence is equal to s minus 1, okay? So he will call array nearly full if it has a sum of s minus 1, that is 1 less than the original sum, right? 1 less than the sum s. So he wants to know what are the total number of such arrays that are possible, and he needs your help to figure this out. So also one more thing, a sequence is or x x is a sequence, x is a subsequence of a sequence y if x can be obtained from y by deleting several possibly 0 elements, okay? So I hope that everyone knows what is a subsequence. Even if you don't know, so we'll be discussing about it in the problem statement itself. And so you have to do this. So let's move to the whiteboard and let's try and see what this question says. So the question, what does the question say? So let's say that let's take a test case. So let's take one test case. Let's take this and let's elaborate this further, right? So let's say that I have 3 ones, then I have this array, okay? So if I have this array, then what are the number of elements in it? The number of elements are 1 2 3 4 5 6 and 7, right? 4 and 3 7, okay? So you have 7 elements, right? So now in this, what you can do, let's try and figure out. So you have to find subsequences such that the sum is s minus 1, okay? So if the sum, what is the sum for this array? First of all, let's try and see what is the sum. So you have 2 plus 3 4 1 5 6 and then 9, okay? So if you have 9, so if you want a subsequence such that it is nearly full or it is nearly complete, so you will need a sum of 8. If your current sum is 9 for this array, then what you will do, your sum that you want to make for this subsequence, it will be n minus 1, sum minus 1, that is s minus 1, which is 8, right? So what you can do is, if you want a sum of 8, then what you can do, first of all, you will be removing 1, right? You can remove a 1, and what is the other thing that you can do? You can remove zeros as well, because removing zeros will be not making any effect on your answer, right? One more thing that I want to discuss with all of you, one more thing. Since your sum, let's say for a particular array that you are considering, the sum is s and the subsequent sum will be s minus 1, okay? So it has to be exactly equal to s minus 1 for an array having sum s that you have picked. So for that array, the subsequence should have a sum of s minus 1. So since you need to have a sum of s minus 1, so you can, the point to be noted is that you can only remove zeros and ones, right? So you can only remove zeros and 1. You cannot remove any element greater than 1. Otherwise you will not be getting this condition, right? S minus 1. How will you get the subsequence such that their sums are s minus 1? So that is why what you will do is this much part I hope is clear. So after this, what you will do is you need to figure out some circumstances. So what can be the possibilities? So let's say you are taking this array, okay? So if you take this array, so you can either take this 0, or you can take this 0, or you can take both, or you can take none, right? So these are the 4 possibilities. Either you take both the zeros, or you take just 1 0, or you take the second 0, right? So these can be the possibilities, or you take both the zeros, right? So there can be a lot of possibilities like this. So since you are considering that, so it will be nothing but 2 to the power of frequency of zeros, right? 2 to the power frequency of zeros. That will be the number, that will be the area where you will be considering that how can you take zeros and not take zeros in your array, right? So you can either take 2 zeros, or you can take this 0, or you can take this 0, or you can take none, right? You can take none. So these can be the possibilities. So that is why the possibilities will be nothing but, for zeros, the combinations will be 2 into frequency of 0. Now for ones, there comes a situation for ones. What is that situation? So for ones, you will be having a special case, right? So since you are having ones, so you will, let's say you have a frequency of ones, right? You have a frequency of ones. So in that case, what you can do is, since you are having the frequency of ones, so at a particular point of time, since you want s minus 1, right, since you want s minus 1, so for the first case, let's say you have these ones, right? So let's say you have the whatever is the number of ones, that is the number of times that you can perform this, or you can have the subsequences, right? So it will depend for a particular frequency. Let's say one is occurring one time, right? Let's say one is occurring one time. So if it is occurring one time, then the number of possibilities that you can have is nothing but 2 to the power frequency of 0, right? But what happens if the one that you have, if it is occurring frequency of 1 number of times, that is the number of times that one is occurring is nothing but frequency of 1, or you can say count of 1. I am taking frequency of 1 in terms of names. So if 1 is occurring frequency of 1 number of times, that is the count of times that it is occurring. So it will be nothing but 2 to the 2 into frequency of 0, 2 to the power frequency of 0 into frequency of 1, right? Frequency of 1, because if for one occurrence of 1, you can have 2 to the power frequency of 0 number of combinations. So in this way, for all you can have this. Let me generalize it more. So if I say that I have count 1, if my count of 0, C of 0 is by number of zeros that I have, and C of 1 is the number of ones that I have. So if I have 1 only one time, then what will happen? The number of combinations that I can have is 2 to the power C of 0, right? But if I have C1 number of times, then what will happen? The total number of possibilities will be nothing but 2 to the power C of 0 into C of 1, right? So this will be my answer. So I'll be just updating my answer like this. So ultimately my answer will be nothing but 2 to the power count of zeros into the count of ones. And I have also told you about the intuition for this. Like for one time you can take 1, then you can consider these ones. So this is how you can consider various circumstances, right? So ultimately the answer will be nothing but 2 to the power count of zeros into count of ones, right? So I'll show you the code for this case, my accepted code. So it is nothing but what I have done is, first of all, I'll be taking n as an input, then I'll be taking all the elements of the array, and you know that it does not matter that the elements that are greater than 1, you have to take them, because you cannot leave them, since the sum will be s minus 1 for the subsequences. Now what you can do is, if your element that you have taken is 1, then you will count its frequency in C, and if it is 0, then you will simply calculate the power of 2, and in the end you will do nothing but 2 to product PRO, that is product, will be storing 2 to the power of count of zeros, right? And you will multiply it with the number of occurrences of 1, as we have discussed in the explanation part. So this is the code, and in case if you have any doubt for this question, you can ask that in the comment section. Make sure to like the video, and the code will be available in the description. Subscribe the channel as well. Thanks a lot for watching.